A cube is constructed from 4 white unit cubes and 4 blue unit cubes. How many different ways are there to construct the 2 by 2 by 2 cube using these smaller cubes? Two constructions are considered the same if one can be rotated to match the other. The way I want to think about this problem is if we draw out a cube here, like this. That, and label the sides like this. So this will be A, B, C, D, and then this little cube back here is E, F, and then H and G is going to be back there. And the way that we can think about this is thinking about the front face of the cube. We have A, B, C, D, and the back face of the cube we have E, F, G, H. And I want to think about the rotation. So if we just do a rotate 90 degrees going around like that, what it'll then turn into, looking at the cube, is going to be so it'll look like then E, G, A, C, D is down here, and then F and B. So when we rotated it 90 degrees like that around, the new back is going to be F, H, B, D, and the new front is E, G, A, C. So now moving on to the problem, thinking about all the configurations of white and blue cubes. I'm just going to use this notation, but know that when I use this notation, I'm referring to the cubes looking like this. So we can break these down into cases, and I'm just going to consider the white colored. So again, let's have this be the back and this be the front. And let's have 2 adjacent in the front and 2 adjacent in the back. And so go like that and like that. And no, I'll just draw it in this time. The blue cubes are right here. So this is one configuration. And so there's one. Next, thinking about still 2 adjacent in the back and in the front, we can write this. And I'll explain why in a little bit, why I'm only considering these 2 whites in this spot in the front. But this is another configuration in which we can color the cube. Now there would be that. This would be another. And so the reason why I'm only considering in the front these is, for example, let's just say, for example, the back and the front. Let's say instead of putting this in the front, I had it like that in the front, and in the back it was like that. So previously we were rotating around like that, but you can also rotate each face clockwise or counterclockwise. So if we rotate a face, in this case clockwise, the front is then going to look like this because these move clockwise, and so will these. So the back is going to look like that. And this is a configuration we've already seen. It's right here. So we don't need to consider that. And that's the reason why the front, it doesn't matter, where these are played. In fact, it's best to fix the WW in these two places in the front and change it in the back, because this is really just the same as this configuration. So these are all different. Moving on to other configurations. So far we have 4. We could do 2 diagonal in the back and 2 adjacent in the front. And again, we can fix this right here and have that like that. And no matter how you rotate it, this configuration will always work. For example, we can rotate this 90 degrees, the same way we were doing in that initial example. And when we do that, the back is going to look like this. Front will look like that. We've never seen this configuration, so that works. Next, I want to consider a configuration where we have 2 diagonal in the back. So this, I'll start numbering these actually. So this is 1 that works, 2 works, 3, and this was 4 that worked. And this was number 5 that worked. And so here, again, if we look at the back, I'll just assume that the back is here. Let's have the diagonals going this way, and again, the 2 adjacent in the front. If we then rotate 90 degrees, it's going to look like this. And this is the same configuration as this, so we've already seen it, so we're not going to count that one. This is the same as this. So next, we can look at when we have 2 diagonal in the back and 2 diagonal in the front. And what that'll look like is something like that. And doing a 90-degree rotation, that would look like that. That would look like that. And we've already seen this before, because again, if we rotate about the faces, we're going to get to something that we've seen before. This would be up here. This would really just be the same as, and we've seen that before. So that wouldn't work. And the next one for 2 diagonals in the back would be like this. And rotate this 90 degrees, it would look like this. We've never seen this configuration, so that would work, and that's number 6. And then now we want to look at where we have 3 in the front and 1 in the back. So again, back, front. So this can be moved, rotated 90 degrees to look like this. And this can just be rotated about the face to be something that we've seen before, because we get 2 adjacent and 2 adjacent. so that doesn't work. Now we'll put the white cube there and still have the same configuration of these in the front. This can be rotated 90 degrees to get this. And this is a configuration that we've never seen before, rotating 90 degrees. And if you keep rotating, we'll still have never seen it. So that works, and that's number 7. And still going with this back and front with the 3 in front. So now let's put the one in back there. These in the front. This can be rotated, and we get this. This is a configuration that we have seen before. So that won't work. Next, the last one of 3 in the front, put there. Rotate it. Get 2 diagonal in the back and 2 adjacent in the front. And we already have seen this configuration. We can rotate about the faces, and it would look like this. So that doesn't work. The last configuration we want to see and check is going to be when we have all one color in the front and none in the back. And this can be rotated 90 degrees, and we get that in the back and this in the front. And if we rotate about the face, this will look like it's the same as this, which will not work. So we've considered all the cases, and we found that 7 configurations are unique. So there are 7 different ways to construct the 2 by 2 by 2 cube using the smaller cubes. So the answer is choice A.